Okay, I think it's finally time to show off the first full end-to-end test of this crazy little NEStronic project I'm working on. So over here we have the NES side of the project. There's an RP2A03G, that's a CPU desoldered from an actual NES, connected to an SRAM chip, and a ROM emulator to make debugging easier, with wonderful auto-tuner gearhead branding on it, but it does actually work. This simulates an EEPROM chip that I can very easily change the contents on without having to involve a crazy EEPROM burner and moving chips back and forth. On the other side, we have an I2C interface chip. There's a clock oscillator, some address decoding logic, and our amplifier. And connected to the I2C input is my oscilloscope. And of course there's a speaker. On the other side, we have on this breadboard an ESP32 with an SD card. And that's the modern microcontroller. And what's going to happen is the ESP32 is going to load a VGM file off of the SD card, decode it, and spit commands via I2C over to the NES CPU, which is going to then execute them. And while this is happening, we can watch it through the wonderful magical world of serial decode on my oscilloscope. So, it's time to kick this off. Let's press the reset button and watch what happens. As you can see, it is playing the Super Mario Bros. Theme, directly from the VGM file this time. And up here on the oscilloscope, you can actually see the raw commands it's spitting across. All of these commands are basically telling the NES CPU to write to specific registers of its audio processing unit. And not much more than that. And, believe it or not, this is actually working. And yes, this is a mixed 5 volt and 3.3 volt system. The NES hardware is all 5 volts except the I2C chip. And the ESP32 is also 3.3 volts. Okay, there we have it. I think it's time to wrap it up.